I recently uploaded a video where I showed how you can race two tasks in Swift concurrency against each other. Basically, what we did is we allowed two tasks to start work at the same time, and then whichever task finished first is the one that would win and give us a result. I then also showed you how you could implement task timeout with a task sleep, as well as a task that you wanted to run. So basically, we're raising the sleep against whatever work you actually wanted to perform, but the sleep would be a timeout. And that got me thinking, and I actually received a few questions as well about the difference between having a task sleep and having a thread sleep. Now, this is a very good question because Swift concurrency wants us to always make what's called forward progress with our tasks. So whenever we do work, we're not allowed to stall or to sort of freeze things up and do nothing for a while. In practice, that means that we're not allowed to block the task for too long. And that's perfectly fine because when we await something, we don't block, we suspend. And suspension is still technically forward progress because when we suspend, our threads can do other work and probably some other function is making progress on our behalf until we return, okay? When we sleep a thread, on the other hand, things are a little bit different. So what I have is a sample project that we can look at to see the differences and how they impact forward progress. If you like these kinds of videos, make sure to hit the like button below. And if you're not subscribed to the channel, make sure to change that right now. It really means a lot to me to get those subscriptions in because the higher the number, the better YouTube thinks the channel is. Anyway, let's get into Xcode and see the difference between task sleep and thread sleep demonstrated. Okay, so I have a pretty plain empty project here, and as I mentioned, tasks always have to make forward progress in Swift concurrency. That's somewhat of an expectation or a rule that is set by the system. So in my demo, what I'm actually going to do is I'm going to introduce a whole lot of task sleeps, and we're going to see how things work. And we're going to see that we can actually continue to add more work as needed. So what I'll do right now is, let's say I'll have a counter, state private var count. I'll set that to 0. And I'll have two buttons, one to call a function and one to increment. And that will just count plus equals 1. I'll throw this in a V stack. And there we go. We'll also show the count like this. And we'll just run the app so that it's cached and all that stuff. So this view on its own, it's nothing too interesting. And what I'd like to set up here is an example where the UI is going to remain responsive the whole time. In other words, we're not blocking anything, we're just doing work and everything is working as we'd like. So I'm incrementing and that works. So now let's see what happens when I maybe launch a new task from within my function, and I will actually await task.sleep for sleep 4 seconds, and I'll give it a 5-second sleep. It's going to be a pretty lengthy sleep. And we'll actually print something, print sleeping task with, and I'll give it an ID. So I'm actually going to make ID equals UUID. So we'll know when are we about to sleep, and then task with ID, we'll call it completing task with ID this. So let's actually see what happens now. Oh, we need to try await that. That's completely fine. I'll click call function, sleeping task with ID, and then it takes 5 seconds for this to complete. And during those 5 seconds, I'll click again. We can increment the count and everything is fine. All right, so this is good. Now I'll click it many times so that we can see that we're actually sleeping a lot of tasks. All right, so we're sleeping, and we're sleeping so many tasks, and I'll just keep clicking, and eventually they'll start completing. So this works perfectly fine. Now let's see what it's actually doing, because we make a task and then we sleep it. So the task is suspended. And when a task suspends, it actually frees up the thread that was running the task. So as we schedule more and more tasks that will be sleeping, threads will be able to pick up those tasks and start running them. Now let's actually do something different and say Thread.sleep for, we'll do until, or 4. Doesn't really matter. For time interval and how many seconds will we sleep for, we'll sleep for 5 seconds. Now let's actually see what happens. We're getting a compiler warning, by the way, that's saying that this is not available from within tasks because you're not supposed to do this, which is really good because you're really not supposed to do it. The point of this video isn't to show you that you can use Thread.sleep. It's to show you the difference between Task.sleep and Thread.sleep and why you should favor Task.sleep. Okay, so we have our Thread.sleep here. Increment still works. I'll call function, we're sleeping a task, and my UI is immediately frozen. So that's not good. We'll do that again. I'll click call function. I'll click it many times, but nothing happens. We're sleeping our task with ID, and while we're sleeping, our UI freezes. Now, the reason for that is that this task that we're creating is created on the main actor, because our view body is on the main actor, and any tasks that we start from the main actor will also run on main. That means that when we say Thread.sleep, we're sleeping the thread that we're currently on, and that is the main thread. So we're sleeping the main thread, and we're telling the main thread to just stop doing work. So instead of suspending a task, we're freezing up the main thread. And that means the main thread is now no longer able to do anything. We can actually change things a little bit by making this task detached. So now we're sleeping a thread that isn't the main thread, and let's see how that changes things. I'll call my function and I can still increment. So that is completely functional. And then after 5 seconds, we'll complete. Now when I start clicking this many times, eventually, as you can see, I'm still clicking, but in the console, nothing is happening. Now we're completing some tasks, we're sleeping some new ones. But Swift Concurrency only gives us a finite number of threads to work with. So at some point, I'll have started a number of tasks that occupy all the threads that are available to me. I'm sleeping those threads, so those threads cannot do something else. So as I keep clicking, I'm scheduling more tasks, and eventually all threads that are available to process my tasks will have frozen up. They'll all be busy, and there's no more system resources for me to use. And that's why Thread.sleep is so bad. It prevents our task from making forward progress because it's blocking the thread that it's on. So that's the difference between Thread.sleep and Task.sleep. Task.sleep allows us to suspend the current task, which means that the thread that was running the task can do other things while we wait. If we're sleeping the thread, we're basically just starving system resources. If you enjoyed this video, make sure to hit the subscribe button, make sure to like the video, and then I will see you again in the next one. Thanks for watching.